G'day everybody, where's Wally here? Well, Adam, he tried to debunk space, or the ISS, or the Russians, or something, but his argument, it's about to come down like, well, I'm not sure how to finish this, but I'm sure I'll think of something. Anyway, on with the derp.
Today I'm looking at the Pirs docking compartment and the Progress 77 burn up as it's left, supposedly, the ISS. Right, now we come to this clip. Obviously this is filmed from the ISS, looking at the undocking of the Pirs compartment, module, whatever you want to call it. Now let me slow this down.
Well, you know you're going to have to slow this down, Adam, because, well, those words, time-lapse, I think that means it's sped up. I bet Adam didn't even notice that little detail, did he?
It cuts in a minute. You'll see the cut come in. Here comes the cut, and notice how the ISS accelerates away from that module.
Accelerates away? Stops dead? Well, I see Adam's total lack of reference frames is at 100% yet again. Now, Adam, the ISS remains at the constant orbital speed of 7.6 kilometers per second. It doesn't change. Now, the Pirs combo, it changed speed by slowing down, but its apparent sync with the clouds just happens to be a mere fluke. Looks rather sweet, I thought.
I've got very basic understanding, so you might have to bear with me.
But let's watch the NASA feed. This one's by Raw Space. Good on you, mate. This is excellent.
Standing by for a thruster firing burn by the Progress to increase its opening rate with the Pirs docking compartment away from the docking port to which the combined spacecraft had been attached to. And the separation burn is now underway. And the burn is complete. Good burn.
The original NASA feed says that the MS-16 Pirs combo did an 8-second burn to increase the separation rate by a staggering 0.42 meters per second. And Mr. 42, I'm surprised you missed that.
Oh dear. Wally, I can't believe I missed that.
Good on you, mate.
Now supposedly 4 hours later, after the undocking, we get this clip, which is very strange because we've just seen that we come back a smidge. They're leaving that module behind, right, as they hurtle around ball Earth, okay?
Adam, as the ISS is hurtling around the ball Earth, the MS Pirs combo is also hurtling around the ball Earth with it. Remember, it just undocked. Adam, I have a question for you. If a train leaves the station travelling at a speed of... Oh, hang on. Let's make this as easy as possible for Adam, shall we? If a crane is lowering a block at a constant speed of 0.42 meters per second, after 3 hours and 5 minutes, how much rope has the crane let out? Let's face it, we'll be here all day waiting for Adam to do the calculations on this one. It's 4,662 metres, or to convert that to kilometres, we divide by 1,000, don't we, Nathan? That's 4.6 kilometres behind the ISS after 3 hours when the deorbit burn started. Not very far.
I've got very basic understanding, so you might have to bear with me.
So here's what I think happened. They undocked at point A. Then an 8-second burn to increase the speed to 0.42 meters per second. Now that likely continued for the next 3 hours and 5 minutes till the deorbit burn. Now at point B, they're only about 5 kilometers behind the ISS, say. Now, and if you doubt that, have a look at how far away it was when the sun set just about 10 or 12 minutes later after departure. So the deorbit burn was only 18 times that. Not that far, Adam, really, is it? Now, the deorbit burn took 17.5 minutes to drop the speed by a further either 120 meters per second or 425 meters per second, depending on the source. Either way, they slowed it down, which meant it would have fallen further behind the ISS. But now at point C, the Pirs MS-16 combo, now slower than the ISS, but it was pointing downwards. They say that it contacted the atmosphere and commenced burn up 23 minutes later. Now that's at point D, and I'm assuming that's around 100 kilometres or so. So from point C to point D it took 23 minutes, and during that time it went from 420 kilometres at the ISS height down to around 100 kilometres to the atmosphere. Now that's one hell of a downhill coast. Particularly no friction, no wind resistance, so it would have picked up a lot of speed in that ballistic trajectory. And increasing speed meant it would caught back up to the ISS to be just in front of it when it hit the atmosphere. You know, it's almost like someone thought about it and planned it out that way. And just before the approaching dawn too, so the nice fireball could be seen against the dark sky. Coincidence or rocket science, Adam?
I don't entirely know exactly what's going on.
Well, there you have it, folks. Let's wrap this one up. Adam, he was wrong in so many ways I couldn't possibly list them all. The funniest thing was he thought the ISS actually lapped the Earth and caught back up to the Pirs module, when in fact it was the Pirs module that overtook the ISS on its fiery descent back down that ballistic path to Earth. Well, Adam, sorry mate, but you got everything wrong yet again, but why are we not surprised? Adam, stop trying to debunk the ISS. You can't. It's demonstrable science, and you're wrong. Thanks, guys. Do that button clicking thing. You know you want to.
So the docking port now open for the Nyoka multipurpose laboratory module, which is expected to link up to that Earth-facing port on Thursday morning. The deorbit burn by the Progress's engines is expected just over 3 hours from now. And again, that will be a 17-minute, 37-second deorbit burn, a braking maneuver to slow Progress and Pirs down by 425 meters per second, allowing it to drop out of orbit for its destructive entry into the Earth's atmosphere.